Hello guys, welcome to our page. I know that you already liked, subscribed and shared our page. So here, without wasting any time, we are going to start the next point from the chapter number 6, Refraction of Light, which is from the SSC syllabus, Science Part 1. Now, in the previous lecture, we had considered about the refraction of light, how that phenomenon is occurred, then how we are going to define the angle of incidence, angle of refraction, like that. Now, in the previous year, we had considered about the reflection of light, and in that we had considered about the Snell's laws. That means we had considered some laws. So those are referred as a Snell's law. Like we had considered that incident ray, reflected ray, point of incidence all lies in a same plane. Then the angle of incidence is equals to the angle of reflection. So these are the previous laws. Now here we have to consider Snell's laws in case of refraction of light. Now that first law is going to be common because similar to that of law of reflection, we have to consider the first law, which we are going to say like this: the refracted ray, incident ray and point of incidence, all three lies in a same plane and they are present on opposite sides of normal. That means incident ray and refracted ray, they are going to be on opposite sides of normal. So that is a common law. But here we have to consider the second law, that means which is another law we have to consider. So now it is like this: for a given pair of media, sorry, so here given pair means there should be combination of two mediums, two transparent medium. So for example, I will say that you can take air and glass, so that will be your given pair. So how many mediums are there? Two, air and glass. Or you can also say air and water. Again, you can also say water and glass. So any pair of media you have to consider and you have to keep that pair constant. That should not change. So that's why the starting of statement is given like this: for the given pair of media, the ratio means you have to take division. That means you have to take numerator, denominator. So which ratio we have to take now? For the given pair of media, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. Constant means does not change. So here the statement is like this: for the given pair of media, that medium should not change. The ratio of sine of angle of incidence to the sine of angle of refraction is constant. And if you change the medium, then that ratio is going to change, but it is going to constant for that particular pair. Suppose I am considering air and glass. For that, this ratio is going to be constant. Suppose its value is 1.54. So continuously it is going to be 1.54. But if I will change the medium, if I will take air and water, in that case the refractive index becomes 1.33, or that ratio becomes 1.33, and that is going to be constant for that particular pair, air and water. So in this way, for the given pair, the ratios are going to be constant. Okay. So here which ratio we are taking now? Sine of angle of incidence to the sine of angle of refraction. So you have to find out the word TO2 and whatever be the portion or whatever be the terms given on the left hand side of that word, that is your numerator, and whatever be the phenomenon or term or quantity is given on the right side of that word TO2, that will be our denominator. So here on the left side it is present sine of angle of incidence. So angle of incidence is denoted by I. So that's why this statement is written in the form of mathematical form. So we are getting sin I divided by sin R, which is equals to constant. So this ratio is always going to be constant, and that constant is denoted by small n. So here what is the symbol for this constant in case of Snell's law? For refraction, the n is a constant, and here that n is referred as refractive index. N is referred as refractive index of first medium to the second medium. With respect to that mediums, we are going to take the refractive index. So this is the Snell's law. Now, what is the meaning of refractive index? That we have to consider. How to calculate it, how to define it, how on which factors it is depend, like that. All the factors we have to consider. So the first thing is that the change in the direction of light ray while entering different media is different. That means how that direction will be changed. That means how will be the angle of refraction, or what will be the angle of refraction is totally depend on mediums. That means light is traveling from which medium to which medium, and depending on different mediums, that angle of refraction, that means change in direction, is going to be different. So it is related to the refractive index of the medium. And why it is happening? It is because of refractive index of the medium. Some mediums having higher refractive index, some mediums having lower refractive index, and depending on that, the direction is different for different medium. So the value of refractive index will be different for different medium. It will be different for different medium. Like I had told you that if you are taking air and water mediums, the constant is 1.33. That means n is 1.33. And if you take air and glass, in that case it is becoming 1.54, near about that. So that means refractive index for different medium is different. And also for light of different colors, for the same medium. That means if the medium is same but color of light is changing, then also the refractive index is going to change. So if you consider the rainbow, combination of rainbow, so basically rainbow is created in the same medium, suppose. That means light is traveling through the same medium, those all 7 colors, but their refractive indices are going to be different. And the important fact is that the refractive index of medium with respect to vacuum, that means if one medium is going to be vacuum, or air, you can also say air, then such a refractive index is referred as absolute refractive index. Same ratio you have to take, sin I upon sin R, no problem, but only the condition is that medium. So the refractive index of any medium with respect to vacuum is referred as absolute refractive index. And another factor is that the refractive index is totally depends on velocity of light in the medium. It totally depends on velocity of light in the given medium. Okay, so this is the basic facts regarding the refractive index. Now we have to consider how to calculate that now. So for that purpose, I am considering one refraction from medium 1, which is air medium, to the medium 2, which is glass medium. Okay, suppose in the air this light wave is traveling with the speed v1, and it incident on that boundary of the glass medium, and after that it is going to show the refraction inside that glass medium. But here at the point of incidence I had drawn the normal n, so due to which we are going to take the angle of incidence, which is I. Then light ray showing refraction of light, and due to which it will enters into that second medium, that means glass medium, and where its velocity becomes v2. Now its velocity becomes v2. So you should know that, or you all are familiar with this fact. The speed of light is maximum in vacuum or air. It is maximum as compared to all the mediums. It is very higher in the air or vacuum. So that means here, as the v1 is the velocity of air medium, so definitely it is going to be higher than v2. So that means here velocity of light wave is going to be decreased when it is entering into the glass medium. Okay, so what is happening here? The density of air is very low, so that's why its speed is higher, and here the density is higher, so that's why velocity is decreased. And as the density is higher, then refractive index is also higher. So in other words, we can say that the refractive index is inversely proportional to the velocity. So you should remember this relation. Inversely means one factor increasing and other factor decreasing, that is referred as a inversely. So here, as the v1 is greater than v2, so that means the refractive index in the glass medium is going to be greater than the air medium, because v2 is less, v1 is higher. Okay, so here angle of refraction is r. So if we take the definition now, or if you want to calculate the refractive index, now here I am going to calculate the refractive index of second medium with respect to first medium. Second medium with respect to first medium. Okay, so here which medium I had taken first? The medium in which that light is going with respect to the medium from which that light is coming. So that is the statement. So it is denoted by 2n1. It is denoted by 2n1. It is equal to the ratio of velocity of light in medium 1 to that in medium 2. Velocity of light in medium 1 to that in medium 2. So that's why we can write it down it like this: 2n1, which is equals to velocity of light in medium 1 divided by velocity of light in medium 2, which is the equation for the refractive index of second medium with respect to first medium. Okay, now if we consider the second case, that means the refractive index of medium, which medium? First medium with respect to second medium. That means now light wave is traveling from second medium to first medium. How it is traveling from second medium to first medium? That means we had changed the direction. Then it is calculated by velocity of light in medium 2 to that in the medium 1. So you have to take the reciprocal of this first equation, 2n1. You are getting 1 and 2. So what will be the equation here then? Velocity of light in medium 2 divided by velocity of light in medium 1. So that is the second refractive index. And if the first medium is vacuum, then the refractive index of the second medium is referred as absolute refractive index, and it is directly denoted by n. So there is no need to take the suffix. So directly it is denoted by n. Directly it is denoted by n. Okay. So here these first two refractive indices, 2n1 or 1n2, 2n1 or 1n2, they are actually referred as a relative refractive indices. They are referred as a relative refractive indices. Okay, so here these are the refractive indices. Now there is some fact regarding this refractive index. I just told you that some medium having the higher refractive index, some medium having the lower refractive index, like that. So if we consider the conditions from which medium the light wave is traveling to which medium. So suppose I will consider rarer medium to denser medium. This is the first condition. So rarer medium to denser medium means the high density and low density, that concept here. Rarer means low density and denser means high density, and that means here low refractive index to high refractive index. So that means rarer medium having the low refractive index and the denser medium have the higher refractive index. Now here if we consider the condition how that light wave is traveling, so here I had considered normal, at which we have to consider the angle of incidence. Okay, so suppose here I had considered the angle of incidence, which is I, and angle of refraction, which is R. So here if we consider the statement, when light ray passes from rarer medium to a denser medium, then it bends towards the normal, that is the angle of incidence is greater than angle of refraction. So it is bending towards the normal, so that means it is shifted to the left side. Suppose if you see, the original path will be like this, and as compared to original path it is shifted to the left side, that means towards the normal, when light wave is passing from rarer medium to the denser medium. And opposite to that of, if light wave is traveling from denser medium to the rarer medium, in that case that means when light is traveling from denser medium to the rarer medium, it bends away from the normal. So that means it will shifted to the right side as compared to the original path, that means it is moving or it is bending away from the normal. So you have to remember these two conditions, which are very important, because in certain cases you should have provided the values of densities or values of refractive indices of mediums. In that case you have to decide which angle is going to be higher and which angle is going to be lower. So if it is traveling from rarer to denser, then I is greater than R, and if it is traveling from denser to rarer, then I is less than R. And when light wave is incident normally, then the direction will not change. So it does not deflect, it does not change its direction, and hence it does not get refracted. So that is not referred as a refraction. So though light wave is passing from one medium to another medium, but direction is not changed, so that's why it is not referred as a refraction. So in this way, this is the concept of refraction and some laws we had considered. So here you can see that the incident ray, which is blue, and refracted ray, which is red, they are present on the opposite sides of normal. So that law you can see that, and on your screen you can see both incident ray, normal, and refracted ray, all you can see at a time on a single screen. So that means they are in a single plane, so this is also correct according to Snells. So this is the concept of refractive index. So in the next lecture we are going to consider the next factor regarding this refractive index also. So twinkling of stars and that concept we are going to consider in the next lecture. So if you haven't watched the previous videos, the link is given in the description, so you can watch those videos from the links which are given in the description. So here, thanks for watching the video. I hope you already liked, subscribed and shared our page. If you haven't done that, please like, subscribe and share our page, and also press the bell icon so you will get updates in the future. So again, thanks for watching the video. Have a nice day.